What's up guys, Harsh here, back in the video. So in this video I have a very cool project. So I am using the Blink app on my smartphone and the Bluetooth module on the Arduino. So this way I am able to control my LEDs from my smartphone without the internet using the Bluetooth module. So as you can see, each of my relays are functioning very good. So without wasting any time, let's get started. Okay, so for this project I am using the Arduino Uno, and it's just a simple Arduino, nothing too fancy about it. So no Bluetooth module or Wi-Fi module built into it. So for that I am using the HC05 Bluetooth module. So it's a pretty tiny module with multiple pin outputs, and we are going to only use 4 of them, which is the RX, TX, ground and VCC. So that way we will be able to power it up and send the data back and forth. Then we will use a simple 4-channel relay model just like this one, and you can easily find this on any of the electronic website which sells these Arduinos and all that stuff. So it's pretty easy to find, and this comes in multiple options. So here I have the 4-channel. You can also get the 2-channel, single channel, or the 8-channel module. So depending upon your use, you can just pick them up as you wish. So let's understand a little bit about the relay module first, then we can go ahead and start with the connections. So each relay has total of 3 terminals connected to them. So this relay has these 3 terminals connected to it. So it has a common input, which is the middle pin, and then a normally closed pin, which is the right pin to it. So this pin, as you can see, it is also printed on the board also. So as you can see that these lines are connected. So this means if the relay is turned off or it is getting a low signal from these pins, which is in this case, as you can see, it is not connected to anything, so it will be in its natural position. So if I supply power between these two, the current will actually flow through the circuit and complete the circuit, and the appliance will remain turned on unless the higher signal is provided, in which the switch will shift to this pin. So then the current will start flowing between these 2 pins rather than these 2 pins, and this is same with all 4 relays. So there are total of 12 terminals, 3 per 4 relay. And then at the back of it you have your inputs for the high-low voltages and the ground and the VCC to power the whole relay channel system, and it can take the 5 volts from the Arduino, and you can also run the Arduino with the Bluetooth module as well. So that's pretty nice. And to connect all these things, I will use a simple mini breadboard, and this is a very convenient little breadboard. You can connect a lot of things to it, especially for this tiny project. As you can see, it is just as big as the Bluetooth module itself. So now let's start with the connection. So I will start with the Bluetooth module. So I will just stick it into the relay just like so, as you can see. Okay, so once you have done that, we can start with the power supply. So we will connect the VCC and the ground first with the help of jumper wires, just like so. So our white wire is the VCC and our purple wire is the ground. So I will take that and I will connect the white wire to the 5 volts of the Arduino supply, which is right over here, and connect the purple wire to the ground of the Arduino, just like so. So as you can see, white goes to the 5 volts and purple goes to the ground. So now we can connect the RX and the TX. So we'll connect the RX to the TX of the Arduino. So the TX of the Arduino is actually pin number 1 and the RX of the Arduino is pin number 0. So I will take the wires and connect first to them. So our orange wire is connected to pin 0, which is RX. So the RX of the Arduino will go to the TX of the Bluetooth module, just like so. And then RX of the Bluetooth module will go to the TX of the Arduino. So as you remember, I have already supplied the 5 volts to the Bluetooth module, and from here I can also supply it to the relay as well. So I will connect the ground to the ground and connect the VCC to the 5 volts of the Arduino. And this is the main reason why I am using a breadboard, because I will need to supply both the Bluetooth module and the relay with 5 volts of power, and there is only one 5 volts output that I can see over here. So that's why I use the breadboard to connect it. And we will connect the input pins. So I will use some jumper wires again and then just stick them in place. ये काट चाहे तो काट देना, speed up मत करना. So I have connected the wires. So brown is input 1, red is input 2, orange is input 3, and yellow is input 4. So this will be connected to the digital outputs of the Arduino. So in Arduino you can see that the digital outputs are marked by a little wave thing. So 3, 5, 6 and 9, these are the digital output that we will be using. So I'll connect the input 1 to pin number 3. Then I will take the input 2 and connect it to pin, then input 3 to pin number 6 and input 4 to pin number 9. And don't worry if you don't understand the connection, the circuit diagram and the code is in the description, you can check that out. So if it's anything confusing for you, you can just take a look at the circuit diagram itself. So now our connections are done for the Arduino and the relay and the Bluetooth module. Now we can just flip the whole circuit like so and then connect our appliances to the terminals over here. So the power will be supplied to the common pins of each of the relays. So the common pin is the middle one for each of the relays. So in this case I will connect it to this and this pin. So I have little wire harness over here. I will just connect to each one of them separately. So just like so, as you can see, I have connected to the common pin, and this is all and these are all connected to the same pin. So this will be our main power input. So we will supply the power through here, and then from there we will take each individual wire to the appliances from the leftmost pin, because it is the normally open condition. So in any case the relay stops working or it malfunctions, the appliance will automatically turn off and prevent any further damage. From my previous video I have this LED panel that I made. So each of this has a power input from these 4 individual wires, and then they have a common ground. So let's connect this to the relay. So as you can see, the outputs from the relay are connected to the left pin of the relay, each relay. So the common pin and the left one is connected to the LEDs over here, and you can get a familiar look over here. So our positive power will go from here and the ground will be connected here. Okay, so now that our connections are done, we can start with the Blink app and program our Arduino. Okay, so now let's open up the Blink app and create on. Okay, so let's open up the Blink app and create a new project. So let's click on new project and we will name it Arduino relay short. Then we will select our device, which is Arduino Uno right here, and then in the connection type we will select Bluetooth. Click on OK and click on create. So first step is to add 4 buttons to the area, and now we can go ahead and program each one of them. So if you want to name it, you can name it, but it doesn't matter what you name them. So I will name it B1 and select my output pin. So it will be D3 as I have connected, and the mode will be to switch, and slide the mode to switch. So in that way it will act as a switch, not as a push button. And once that's done, we can just go ahead and do the same with every other switch. So I will name it B2 and select the pin output, which is D5, and then set the mode to switch. And then for the last button we will name it B4 and assign the pin D9 to it, just like so. So as you can see, now we have B1 assigned to D3, B2 assigned to D5, B3 assigned to D6 and B4 assigned to D9. Next up we will add a Bluetooth widget so that we can connect to the Bluetooth module. So we'll click on that, and as you can see, this is the Bluetooth module that you will get, and you can place it wherever you like. So I will place it in the middle over here, just like so. Now once this is done, we can go ahead and program our Arduino. Now before we can do anything, first of all we need to do 2 main things, that is install the Blink library and make our Arduino IDE compatible of coding the ESP Node MCU board. So first of all we will add the Blink library. You can do that by going to Sketch, then go ahead and click on Include Library and then Manage Libraries. This will open up this small window, and in the search bar you can just simply type blink and then press enter. And as you can see, it will show the blink library on the top, at the very top, and you can go ahead and click on install just like this option, and it is already installed in my system, so that's why no option is showing. And once it's done, you can just go ahead and click on close. Okay, so after installing the blink library, now we can go ahead and start with the coding. So the coding you actually don't have to do, but just you have to choose an example from the blink library. So just click on files and then go to examples, and then scroll down to blink, right, which is right over here, and then select on boards Bluetooth, and then select the serial HC05 underscore HC06. So this will work with HC06 and HC06. So this will work both with HC05 and HC06 modules, and once you click on it, it will open up the new window, and here is the actual code that you need to upload to your Arduino. So the code is pretty lengthy. Let me just remove the comments line and show you the actual code that we need. So as you can see, after the cleaning, it only this much of code is left, and you have to paste your authentication code right over here. So this will be sent to your email when you created the blink project. So just remove this line and paste your authentication code just like so. So it will look something like this, and once you are happy with that, you can just go ahead and go to tools, select your board, which is Arduino Uno in this case, just like that, and then select your COM port, which will be different in your case. So in my case it is COM5, and in your case it might be COM3, 2 or whatever, so don't worry about that. And once it's all done, you can just go ahead and click on upload, and this will upload and compile the code to the Arduino. Okay, so at this point, if you have done everything correctly, this should be like so. So as you can see that the LED on the Bluetooth module is flashing pretty fast, so it is in pairing mode, as we can tell, and I'm using the USB power supply to power up the Arduino, and the Arduino is supplying power to the relay and the Bluetooth module. And as for the time being, I'm not connecting anything to it because I need to test my connections first and check whether the relay is working or not. So on my smartphone, I will just click on the Bluetooth icon over here and click on connect Bluetooth device, and this will ask for the location permission. So I will click on enable and go back, and this will search for any Bluetooth device in the area and make sure that the Bluetooth is turned on. And as you can see, it has already found the particular Bluetooth module, so HC05 it is. So then click on OK, then click on back, and it's all done. Now we can go ahead and just click on the play button over here and check whether our connection is going or not. So if the module is connected to the phone, you can actually see that the light is now flashing at certain time, but not as fast as before. So I will just check the connection. So as you can see, it is kind of working in reverse. So when it's showing off here, it's actually turned on the relay module. As you can see, all the 4 lights for the relay are turned on actually. So we can fix that just by simply renaming the buttons, and this will work fine. So if I click on the button, as you can see that the relay is turned off now, and it is same for all the other options. You can see all the lights on the relay are working and functioning as per the directions that are given to it. So now we can finally power up our LED module from the battery or whatever you like. Okay, so now I have also powered my LED, so let's just try the buttons. So as you can see, the first one works pretty fine, and then let's start with the second one. So that's also works pretty good. Let's try the third one and the fourth one. So as you can see, I can turn them all at once and turn it off. And the good thing about this project is that the data is not actually sent to the Blink server, it is just the connection between the smartphone and the Bluetooth module itself. So none of your data is going out of your house. So this is pretty nice. And as you probably remember, I did an IoT project with the ESP with the same setup and same apps and button layout. So that will require your data to be sent out to the Blink server, and you will need an internet connection for it to work. So this is a pretty nice upgrade from that, because it will use Bluetooth and you will not need a Wi-Fi router to connect it, and every phone has Bluetooth now. So this is a pretty simple project to have if you don't have a stable net connection. Okay, so now that we have made this huge mess on my table, now we can move on to the next phase, which is to see how we can add a manual switch to it, so we can have both manual and remote control for the LEDs. Let's check the connection. Now to add manual control, I will be just using a single channel relay module as to make the connections a bit easy to understand. So this is a very messy situation, so I will be just using a single relay, and you can just rinse and repeat this process for each of the individual relay, and you will have full manual control over any of the device. So in this relay, as you can see, it actually has terminal on both the sides. So we know that this is the main terminal that will connect our appliance to it, because as you can see, it has the same marking as the 4-channel relay. So this is the normally closed terminal, the common terminal is in the middle, and the normally open terminal is right over here. And then at the back we have the VCC input and ground for it as well. So I'll just connect my pins to it and we'll go from there. Okay, so now we have connected the wire. So the green wire is for VCC, so we'll supply 5 volts to it, and the purple wire is the ground, so obviously it will be connected to the ground. And then blue wire is our input wire, so we'll connect to any of the 4 pins that we connected earlier. So in this particular case, I will just connecting to pin number 3, so that we will have a switch already assigned to it for it to work. Okay, so the blue wire is the input pin for the relay, so it is connected to pin number 3, and then the ground and VCC is connected to the ground and VCC of the Arduino, which is right over here. Now we can go ahead and do the connection on this side. Now in the technical term, this is actually called a SPDT switch, which is stand for single pole double throw switch. And for this to work, you will also need another single pole double throw switch. So this is a simple switch, and the main indication that it is SPDT switch is that it has a total of 3 terminals. And if you look closely at your normal electrical switches, it has only 2 terminals. So make sure you get the 3 terminal switch. And the another name for this switch is two-way switch. So this switch is never actually turned off in any of the conditions. So as you can see, it has only 2 position, which is toggled by just pushing it back and forth. So in particular case, the current will be flowing between these 2 pins, and if you switch it to this direction, the current will be start flowing between these 2 pins. So this is actually never turned off, and it has some sort of connection going through the pins. We will be using all 3 of them. So the middle pin is always the common one, and if you have a different pin, it is pretty easy to figure out. So let's start with the connection. So I will just get rid of the middle pin first for a second, and then just take the 2 most extreme pins, which is the leftmost and the rightmost, and connect it to the normally closed and normally open terminals of the relay. So just like so. Now we will need to connect another piece of wire to the middle portion of the relay. So once you have done that, you can see that there are now 2 wires coming out of the connections that we made. So at this point you can see a pretty familiar pattern. These are 2 wires, so this will be connected just like a simple switch with the appliance that we are going to use. So the power will come in through this pin over here, and it will go through these 2 terminals or switches, and then come out this way and go to the appliance, and then the appliance will be connected to the ground. So let's just take my single LED portion over here and connect the power to it, just like so, and connect the switch to it just like so. power to it हटा देना. And then the black wire coming out of the LED will go to the ground, and this black wire that is going to switch will go to the positive power supply. So now let's just connect these. Okay, so as you can see, I have not even turned on my Arduino. As you can see, it is not plugged in any way. So in that condition too, my LED is now glowing, and to turn it off I can just do it by using this switch over here. So as you can see, the switch works pretty fine with or without the Arduino being plugged in or powered in any way. So now let's power up Arduino and see if the relay side of the module works. Okay, so a little bit of disaster has happened on my side. So my single channel relay is not actually working. I don't know why. So that's why I have connected the single module of my 4-channel relay in the same fashion. So nothing too complication over there. So let's just try it out with the 4-channel relay. So as you can see, my switch still works, and let me just take off my phone and use my command to control it. So as you can see, it still works from this side. Let me just put it over here. So as you can see, and if I do the switch over here, it also works from this side as well. And in the special condition, the switch's position will be reversed, so you need to keep that in mind, but still it's a pretty nice feature to have. Alright guys, so thanks for watching the video, and I'm really sorry about this mess that I created, but still the relay is functioning pretty fine. And if you want all the circuit diagrams, it is given in the description, you can check that out, and the code is in the examples, you can just grab it from there. So thanks for watching the video, please like, subscribe and share, and I'll catch you all later.